Thank you very much for inviting me, Nadine, for speaking at the GSSA forum. I'm Josepha Zielke-Olivier, and I'm a geohydrologist. I'm currently working for a consulting company, and I also still trying to finish my PhD while working. So it's a bit challenging at times. And I'd like to give you a bit of an idea of what to expect from a hydrogeological career, except for getting wet in the field. I'm going to give you a little bit of an introduction what hydrogeology is about and what to expect from our work and also how to become a hydrogeologist, about the career opportunities, and also what to expect from you, what skills should you bring, and what does this job has a future. I would like to start it off with a little meme. A lot of times when people ask me what do you do, then you get the big question mark in their face, and so they probably have their own understanding of what you've been doing and what you actually do. For instance, next to a little bit of field work, a lot of your time you also might be spending in front of your screen sorting data, and if you're lucky in a remote area, you might have to add a drink next to you to enjoy the evening, or if you're working nicely from home. So what is hydrogeology? You can also use it interchangeably with geohydrology. There's not really a difference. So maybe where you want to put the emphasis, whether it's more geologically related or whether you want to emphasize it on the hydrological part. But they both mean it's the study of groundwater. So whatever water flow is related to the subsurface, and also the recharge. So how does the water get into the ground, considering different soil types and your rock types, and the different types of flow there. So there's a lot of theory related to that, of horizontal flow versus vertical flow, and if your aquifer is fractured or is it porous. So it's that's it in very broad. So it's a study of the flow dynamics of water under the subsurface. So in practical terms, you're dealing a lot with groundwater pollution in the mining industry, or it can also be agriculture related, and obviously on the urban development. So that it doesn't happen that water supply is constructed downstream, for instance, from the pit latrines. And mining related, any pollution plumes, to monitor them, what's the background before, and what are the issues involved with groundwater pollution. Then the other aspect is water supply and management. A big part would be water use licensing for your clients, for instance, or how can the client adhere to the regulations? Then it's involved in artificial recharge, for instance, or abstraction, and the sustainable use of water. And it's a lot of field work involved, but not necessarily. So if you're maybe not too keen to go out in the field, although I think that might happen much earlier in your early career, that you often will be involved with field work, but there's also an opportunity to stay indoors and sort data and write reports in form of desktop studies. So what a stretch is, you might get away with field work, but you're definitely not going to get away with report writing in your hydrogeological career. So what can we expect from this job? So you can either go into groundwater modeling direction. This involves first of all, a desktop study. So usually your client will provide you with available data, and you might do also a gap analysis. And so you might end up going back into the field to try and gather additional information, or your client might do this himself or outsource that. And from all the information, you try to establish trends and pollution sources. From there, you're going to establish, you conceptualize your setup and your situation and your problem. And from there, you can then develop a numerical flow and transport model with available software, which is, for instance, a free flow or spring is a few that are being used in the industry, and you can model, for instance, your pollution plume movement over a certain extent of time and see how do the concentrations change, and from there what do we need to manage with that respect. And again, in the end of the day, you're going to have to write a model report, which you're not going to get away with. The other aspect of hydrogeological work would be geochemical assessments. There you have geochemical models and geochemical assessments. The geochemical modeling involves software just for example, Freak C or Aquachem. There you can have different types of groundwater sources, and you mix your different water types and see what can, for instance, precipitate out, or what will go into solution. And predictions is also important. If you maybe want to introduce water back into the ground, how would the chemistry change? That's one aspect of geochemical modeling. And geochemical assessments include, for instance, acid-base accounting. If you are working at the mine, for instance, you might have any form of mine residue that needs to be stored either underground or in discard dumps or waste rock dumps. You need to, or the client often needs to know, well, what type of seepage quality am I going to have from this material that I'm going to store, and how would it then impact my groundwater quality? What pollutants, potential pollutants am I dealing with? And that also often relates to how am I going to handle this type of waste? Then do I need to mix it? Do I need to contain it, or can I just store it the way it is? And therefore, for instance, it's important to assess the acid potential or the base potential in the seepage that can evolve from your stored material, or the net acid generation. And you also need to be able to analyze the data and to determine what material it is with XRD and what's the chemical composition with XRF analysis. And it also involves the leach test from your materials under different conditions in order then to establish a waste classification for the client. So that's also something you'll very likely be confronted with. And then there's specific regulations how this waste needs to be stored. Then we have hydrogeological reports that either just assess the groundwater types in the area. There will be aquifer vulnerability assessments, depending if there's a new site establishment, any buildings that need to be constructed, or some new industry complex. And then there would be an assessment on how could it impact your aquifers in the area. Are they high risk or low risk because they're susceptible to pollution rather than others because they're more permeable or more fractured. And then you'll also likely be involved in EIA's environmental impact assessments on isotope studies. So I just have a few pictures here, a few graphs from some of my work, where you can just see, for instance, from isotope studies, you can, for instance, group different water types. You can see if there's been mixing occurring of the recently, has your aquifer recently been recharged, or is it an older aquifer from underground that has been lying there for thousands of years perhaps. So there's different concentrations you can measure it at. And you can have, for acid-base accounting, there's different parameters you're going to assess your net acid generation, or your basic potential. And there's also different tools to assess your groundwater types. So you can also see if they have been mixed and where do they originate from, to track different sources. And you can always from there develop a conceptual model. For instance, on the left side, if you have different tools together like geophysics and your water levels and your chemical concentrations to establish your flow paths, for instance, from a potential pollution source. And so there's lots of opportunity and lots of different aspects that need to be let in the end together to get the bigger picture and establish a conceptual model. And then you'll have the other aspect of field work. For instance, you might be involved with ground geophysical surveys involving electrical resistivity tomography, where you measure different resistivities of the subsurface of different soil types and rock types, or also its electromagnetic or magnetic properties, and that is often to site boreholes or to identify groundwater flow paths, and yeah, also to confirm just the geology. So I have an image here at the left bottom where you can see analyzed interpreted results from the electric resistivity tomography and also from the electromagnetics together. It's just interesting to see where you have the light blue. This is a higher conductive area that's right next to a discard dump. You can definitely see that you have seepage there. So it's a nice confirmation to see what's actually going on underground. And you will also use it to site boreholes. You will be involved likely with drilling supervision and setting up, constructing boreholes for either water abstraction or maybe for recharge. You always obviously have to have a look at your geology. So there will be some core logging involved, pump tests to determine aquifer properties and determine the sustainable yield. Often your client wants to know, for instance, how much water can I abstract over a certain amount of time to protect my resource? Or maybe you want to know how much water do I need to extract to pump something to get the area dry, because maybe for building or for mining. Yeah, and then you also be involved in monitoring programs. Usually mines or industries have a set monitoring program during the year that's continuous. We need to monitor either the water levels and the chemistry. Is there any changes to pollution bloom migrating, or for early recognition if there are issues coming up. And then we'll obviously also sample collection. Then if you have to go into the field, either retrieve your core samples or your water samples. Yeah, and you can in a broad spectrum divide probably where you can expect to work into two sections, either the research component and then the industry. So if you choose the more research path at research institutes, you'll be likely to be involved with lecturing and part of consulting. Sometimes the industry will come back to you and say, well, we have this particular research question, can you assist us? And you liaise with your client. So that will be a bit of mixed work, except for just your pure research. And if you go into industry, you're very likely to end up either directly as a geohydrologist before the mining house or for a consulting company. And then, as already addressed broadly, those three aspects where you might be involved is water management or into the modeling component or the geochemical assessments. So for the water management, it will either be the water supply, where you might have to establish water well fields or storage of excess water for times when there's not enough surface water available for water supply. Or, as I also mentioned earlier, there will be the dewatering aspect a lot of times for the mining industry, if they need to have a pit dry to reach the resource, or also for underground mining for health and safety issues. And that obviously needs to be monitored either way, whether you're going to need to extract water sustainably or if you need to dewater, that both will be involving monitoring of your water level. And if you're working with pollution control, then you will need to monitor the water quality in order to try and maintain contain your plumes. Or you'll be involved in environmental impact assessments, depending on the job involved and the problems. And you might assist your client in water use license applications and regulations. For instance, if there is a new industry starting up, you would need to know what's the background qualities, and then there will be particular regulations on how much water you can store, how much water you can abstract or release back into the system, at which concentrations, and there's going to be a leeway on if there's potential pollution there, how much are you allowed to alter the system. So those clients would would need to assistance in either applying for one or with alterations of the existing water use license or an extension. And yeah, the modeling, the groundwater flow and transport, modeling to predict pollution plumes over certain time periods. Also, a lot of times it's required for mining closure, for monitoring afterwards, and whose liability it is, how much money needs to be set aside for groundwater protection. And then you have those geochemical assessments where you predict the drainage, seepage, water quality associated with any mining residue, and for instance where you have the asset-based accounting and waste classification related to that. So how do you become a hydrogeologist? I think most of the time it's a postgraduate degree, and that's followed by a science-based undergrad degree. I can always stretch that it's quite important to have a good geological knowledge, although I know some universities only require first year basic geology, but I think it's one of the fundamental aspects of hydrogeology. If you're good geologist and you know your rock types, you have always a good indication of how your water is going to behave underground. That's why I think this is something, the more you know about the geology, the better and easier it will make you on your path to becoming a hydrogeologist. Yeah, or a lot of times you have to have studied something in earth science and environmental science. And it's also always required that you have some basic chemistry and math knowledge, and also can stretch that the more chemical knowledge you have, the easier it's also going to be on your path through, because it's always important to know how the chemical reactions are. It's very important when you look at the chemistry of groundwater and the rock-water interaction, what is going to happen. So chemistry is really an important aspect, and obviously you need to know the basic of maths for that as well. I just used for the BSc honors degree in hydrogeology from the Institute of Groundwater Study, an example for the subjects one can expect. This is where I studied. That's why I'm familiar with the courses, but I'm sure if you attend another university and you study there, they'll all touch on the same components, such as groundwater, hydraulics, where you learn the basics of different groundwater flows and interaction and water types. And also, I'm not sure during Corona now, but it used to be also a lot of field work involved in how to do pumping tests and the properties of aquifers. And that is another component is hydrochemistry and pollution. Then you have an introduction to geophysics, because either you're going to be involved in doing it yourself, or you're going to get the data at least that you can interpret it. And there will be touching on mining hydrology, groundwater modeling. There will be also an introduction. Usually, if you're going to go into this field, obviously it will involve a much more experience than that, but it's at least an introduction into it. And yeah, everything that comes with groundwater management and legislations in the country you're working with, and that is usually can then obviously be topped up with some research in the form of a master's and a PhD degree. So what qualities should you bring with, and what skills and what is expected from you in your job? So what is, as I already stressed before, report writing is something you're not going to get away with. It's always going to be a big component. It doesn't matter in which direction you're going to go. And then you should have a basic computer knowledge, because there will always be data capturing and interpretation and analyzing trends involved. So you'll be able to work with the basics. If you have a bit of GIS knowledge, that is also always good, although a lot of times companies might have their own person that is good with an expertise in that. But if you may be sitting remotely somewhere, it's always good if you can plot your own maps and overlay your own things and know where you go. So you cannot always count on someone assisting you while you're in the field. Yeah, you need to be willing to travel, to go to remote areas, usually mining, or we need to have water supply, maybe with a community somewhere. yeah, that might not always be under the best conditions. So you must be willing to go to remote locations. Well, but there's other options as well. If you cannot work outdoors for some reason or go away, there's always this option of having a more desktop bound career path with the modeling, for instance. Yeah, and you should have skills in management and planning. A lot of times, if you maybe work for a smaller company, you'll be able to set up your own project. How are you going to get there? How are you going to perform your tasks, and how you're going to come back? And yeah, you need to be able to handle situations in the field. A lot of times things don't work out as you expect. You need to have communication skills with your client, or if you go, if for instance, have water supply for a village somewhere, you need to be able to explain to them what you do, and might need to be sensitive for how they feel if you intrude and telling them, well, I'm coming here with this drill rig and I'm going to supply you with water, but you're going to need to take care of your water source. So yeah, the communication skills are quite important, and self-initiative, I think that would count for any other job as well. Critical thinking and problem solving, knowledge of fundamental geology, understand and interpret maps and geographical data, and then yeah, at least some maybe basic numerical and chemical modeling skills. But I think if you go into a modeling field, then obviously you always get introduced to modeling courses and deepen that, because that's what you get introduced to at university is just the introduction and a tool, and you need to learn how to use it, and obviously that comes with experience. Yeah, what is expected from you in your job? Well, a lot of times data capturing, analysis, and interpretation. Yeah, sometimes geophysical work, then drilling supervision, and designing of well pumping tests, and yeah, ensure compliance with environmental legislation and conceptual model design, as well as keep up to date with the technology and in any changes regarding legislations. And how to find work and what are the opportunities. Well, I think hydrogeology is quite an emerging field, and I think for the future it will be so important, especially with climate change. We have countries that always used to have sufficient water supply are starting to run out of it, and they need to look into extra resources, which usually then goes into groundwater. And yeah, so what is important is any other search for a job. Well, you would be these days looking online actively for openings in the consulting area, or in the federal, state, and local governments will also be job opportunities in water management consulting, or you might be looking for a job in the engineering services. They also work together with hydrogeologists. And what's obviously very important is to create context, to do actively networking when you still have an opportunity at conferences, and yeah, get yourself out there, present your work, find out what other people do. If you can, maybe take little holiday jobs, not always important about the money, but gain some extra skills and do that little bit of extra work, go the extra mile, as in the picture. You've drilled so deep and come so far, and then you might just needed those extra few meters to reach your resource. So I think that's applies for any different type of job. And to round it off with, there's some useful links for you. You can just have a look, additional information, and yeah, where to study. This is not just 2 university examples, but I mean, you can always Google other universities in your area would like to study if they offer something like this. And yeah, get in touch with different hydrological institutions to see what opportunities are waiting there for you. Yeah, thank you very much for listening.